Good evening. Now we are going to be with second lecture, that is a revision lecture for design of steel structure. Now we have given determine tensile strength of angle 150-1158 millimeter is connected with gusset plate 10 mm. Use 6 mm weld of length 140 mm on one side and 60 mm on other side. Weld is also provided to connected leg. And then we have to find out the tensile strength. So now step one, same. So given data, step one, given data. Angle given is 150 by 115 by 8 millimeters. Gusset plate 10 millimeters. Weld 6 millimeter. Weld size 6 millimeters. Now weld length 140 on one side, 60 on other side. Weld is provided to connected leg also. So now that we will see when we will go to, we will plot actually the welded connection when we will go to design of tensile strength due to rupture at critical section, and at that time we will draw this connection, that is welded connection, and there we will show all these values. So now we will go then first, that is step 2. Tensile strength is minimum of. Now we have to go only for two. One, that is yielding of cross section. And B, a rupture at critical section. A rupture at critical section. So now we will go with this A part. So yielding of cross section. This is denoted by TDG, yielding of cross section. So we have TDG is equal to AG Fy upon gamma mo. And then we have given AG, that is given 2058 into 250 divided by 1.1, and we have this value 467.73 into 10 raised to 3 Newton, which is equal to 467.73 kilonewtons. Now keep in mind, whenever we have welded connection, so we have this connection as welded connection, then we have to consider only two criteria. One, that is yielding of cross section, second rupture at critical section. Generally, welding will not be, or tensile strength due to welded connection is not considered by block shear, and therefore you have to go for A and B only. We are not going to be block shear strength. So we have A, yielding of cross section, then we have B, rupture at critical section. So we have B, rupture at critical section. Though in class or in our videos we have calculated it, so some books are solving this, but in examination you need not require to go for block shear strength. You have to go only for two. One, that is yielding of cross section. Second, rupture at critical section. and we have TDN equal to 0.9 ANC FU upon gamma ml plus beta AGO Fy upon gamma MO. This is gamma ML. So now here we have we have to connect longer leg to this. So now here we have simply ANC equal to D minus T by 2 into T, no whole. D we have 150. So we have 150, 1158. So minus 8 by 2 into 8. And we will get this value equal to 1168 millimeters square. Then go to AGO. We have B minus T by 2 into T. We have 115 minus 8 by 2 into 8. And we will get this value that is equal to 888 millimeters square. Now, if I will plot the connection, then we have connection in this fashion. So we have given 140 millimeter on one side, other side we have 60. So 140 will be on which side? So 140 mm should be on leg side because centroid will lie somewhere here. And therefore more force will be on this side, and therefore we have 140 millimeter on this side. So this will be 140 millimeters. And other side we have 60 millimeters. So we have on this side that is 60 millimeters. And then that is mentioned connected leg also welded to it. So we have this also welded with gusset plate. So we have these are the welds. So this will be 150. If you will plot cross section of this, then you will have this cross section that we have gusset plate in this fashion. And then angle section is connected to it. So we have in this way. So we have this leg. So connection we have over here. Here. So this leg we have 150 and outstanding leg we have 115. And now we will calculate value of beta, which will be 1.4 minus 0.076 W by T Fy upon Fu and Bs upon Lc. Now we have W, which is outstanding leg 115 millimeter. T we have thickness, which is 8 millimeter. Fy 250, Fu 410. Bs now we have W, that is outstanding leg. If you will go to figure 6 in IS 800, then you will get Bs equal to W in welded connection. And then we have 115 millimeters and LC. Now some books are given higher value of LC. Some books are given average of the two. So I will prefer that is larger length because we have this will be LC. If we will put over here, then we are going to get this beta value. That this value we will get LC by putting 140 millimeters. Now you can have average or you can go with 140 mm. So that will not affect answer a lot. So otherwise average 140 plus 60, that will be 200. And that we can take also 140 plus 60 upon 2, and that becomes your 100 millimeter. So you have to decide it, which value you have to consider. And then from this we will get beta 1.4 minus 0.076. W we have 115 upon 8. Fy we have 250 upon 410. BS we have 115. LC we have 140. And then if we will solve this, then by solving this, value of beta we will get it as 0.853. So we will consider it 0.85. So we can check it once. So we have 115 upon 8 multiply by 250 divided by 410 multiply by 115 divided by 140 into 0.076 and plus 1.4. So it comes 0.85. And now we will put it in TDN. So we will get it as TDN equal to 0.9. ANC we have 1168. FU we have 410. Upon gamma ml we have 1.25 plus beta we have 0.85. AGO we have 888. Fy we have 250 and gamma mo we have 1.1. And by substituting this value, we are going to get TDN value that is equal to 516.95. 516.95 into 10 raised to 3 Newton, which is equal to 516.95 kilonewton. This is 2 and 1 we have calculated, which is 461.73, and therefore we have TD equal to 467.73 kilonewtons, and therefore tensile strength of angle 150-1158 is 467.73 kilonewtons. Now instead of 140, if you will put value, this value 100, then what value we will get? Means if I will put it as 1.4 minus 0.076 into 115 upon 8, 250 upon 410, 115 upon 100. And if you will calculate this value of beta, then we will get this value of beta, that is 115 divided by 8 multiply by 250 upon 410 multiply by 115 divided by 100 into 0.076 minus 1.4, and this comes 0.63. So we will have once 0.076 into 115 by 8 multiply by 250 upon 410 multiply by 115 divided by 100 minus 1.4. So 0.63. And if you will calculate TDN for this value, then we will have this as 0.9 into 1168 into 410 divided by 1.25 plus now we have 0.63, which is beta, into 888 into 250 upon 1.1, and it comes 471.93. Means now if I will write for values over here, so you will not confused with this. So 0.9 into 1168 into 410 upon 1.25 plus 0.63 into 888 into 250 upon 1.1, and this comes 471.94 into 10 raised to 3 Newton, which is 471.94 kilonewton. So again, our tensile strength will be this. So we can have any value that doesn't better. Now you can see. So which value I have to consider? In most of the books it is given 140, but if we will consider actually the economy or what we have to consider exactly, then preferable will be average value. Why average value? Because LC will be in denominator. If we have lesser value, then if this is lesser, then this will be greater. And if this component we have greater one, then automatically beta will be reduced because greater value will be deducted from 1.4. So average will be best one, but most of the books are given value as maximum value. So you can decide because IS code does not given anything. So by IS code, we have to consider maximum distance and therefore it is 140. So you can go for any value in examination in same, both will be considered. So this will be about your tensile strength and that is due to welded connection. So we will stop here only. So remaining part we will see in the next lecture. Thank you.